An aircraft took 3 hours to fly from P 65 degrees north, 45 degrees west to Q 65 degrees north, 15 degrees west. The aircraft then changed its course and 7 hours after leaving Q arrived at R 0 degrees, 15 degrees west. The flight from P to Q was along the parallel of latitude, and from Q to R was along the meridian of longitude. Calculate correct to 3 significant figures: the total length of the journey, B, the average speed of the aircraft. P is 65 degrees north, latitude 65 degrees north, and longitude 45 degrees west. Degrees west. So this is point P. To Q, 65 degrees north, 15 degrees west. Longitude 15 degrees west. Point Q. And then the aircraft then changed its course, and 7 hours after leaving Q arrives at R 0 degrees, 15 degrees west. 0.0 degrees is the equator. This is the equator. If point R would be here, since it's 0 degrees, so and 0 degrees is the equator, so this point R, and then 15 degrees west, or longitude 15 degrees, so this R flies the direction of the aircraft. So this is the diagram, and so the flight from P to Q was along the parallel of latitude, and from Q to R was along the meridian of longitude. To calculate correct to 3 significant figures: A, the total length of the journey. So let's get A. So first of all, let's get the length of the journey from P to Q, and that's along the parallel of latitude. The flight from P to Q was along the parallel of latitude. So distance PQ along the parallel of latitude 65 degrees north, go to theta 60 degrees times 2 pi r cos alpha. Angular difference in longitude, since both points are lying on the same parallel line of latitude, the angular difference will be in magnitude, and that will give us 15 degrees. Both points are on the same side of the globe, so we're going to subtract 15 degrees minus 45 degrees minus 15 degrees. That will give us 30 degrees. And next is distance PQ. 30 degrees divided by 60 degrees times 2 times pi is 3.142. 3.142 times 6,400 times cos 65 degrees. So 30 here is 1, 30 here, 12, 2 here 1, 2 here 6. So 3.142 times 6,400 times cos 65 8498 8498.346 divided by 6. 8498.346 divided by 6. 11416.391 kilometers approximately. So three significant figures will be 142,1420 kilometers to three significant figures. So B, no, not yet. So that's distance, distance PQ. The next one is to look for distance. We've gotten PQ and distance QR. Because the question says, A says we should get the total length of the journey, and there were two phases of the journey. The first phase was that the aircraft flew from P to Q, and that was done along a line, a parallel line of latitude, 65 degrees north. And the next phase of the journey was that from when the plane got to Q, it changed its course to R, traveled from Q to R, and that was done on the line of along the meridian of longitude. So we've gotten the value for distance PQ. So let's get the value for distance QR. Distance QR along the meridian of longitude is equal to theta over 60 degrees times 2 pi r. So angular difference in latitude theta is equal to, so angular difference in latitude, both of them, this is latitude 65 degrees north and this equator, which is 0 degrees. So that will give us 65 degrees minus 0 degrees, since both points are on the same side of the globe. So this will give us 65 degrees. Angular difference is latitude 65 degrees. So distance PQ, so distance QR is equal to 65 degrees over 360 degrees times 2 times 0.142 times 6,400. This will give us 65 times 2 times 3.142 times 6,400. 2614144 latitude 60 degrees. 7,261.51 kilometers. So the nearest, the three significant figures will give us 7,260 kilometers to two significant figures. So therefore the total length of the journey is equal to PQ, distance PQ plus QR. So PQ is, I'm not going to work with this approximated value, I'm going to work with this main value. So 1416.391 plus 0.142 plus 7261.51 kilometers. So 1416.391 plus 7261.51 8677.921 kilometers, approximately 8700 kilometers to 3 significant figures. So this is the average. That's the total length of the journey, not the average. It's the total length of the journey, and it's gotten from distance PQ and Q, distance PQ plus distance QR. So the B part says the average speed of the aircraft. The average speed is equal to total distance covered over total time taken. Total time taken. The average speed of the aircraft is equal to the total distance taken. Already gotten the total length of the journey here. That's 8677.901 divided by the total time taken is first 3 hours plus 7. So this will give us 8677.901 divided by 10, and that will give us 867.7901 kilometers per hour approximately. So 3 significant figures will give us 868 kilometers per hour to 3 significant figures. Two points K and Q are on the parallel of latitude 46 degrees north. The longitude of K is 130 degrees west, and that of point Q is 103 degrees west. The third point P, also on latitude 46 degrees north, is on longitude 23 degrees east. Calculate A, the length of the parallel of latitude 46 degrees north to the nearest 100 kilometers. B, the shorter distance between K and Q correct to the nearest 100 kilometers. C, the shorter distance between Q and P measured along the parallel of latitude to the nearest 10 kilometers. Take pi to be 3.142 and R to be 6,400 kilometers. So let's get the diagram. So 2 points K and Q are on the parallel of latitude 46 degrees north. For 6 degrees north. So the longitude of K is 130 degrees west. K longitude 130 degrees west. So this point Q, and that of Q is 130 degrees west. And this is longitude 130 degrees west. So this is Q. And a third point P, also on latitude 46 degrees north, is on longitude 23 degrees east. That is longitude 23 degrees east, point P. Okay, so the question says, A, the length of the parallel of latitude 46 degrees north to the nearest 100 kilometers. Okay, so the length of the parallel of latitude 46 degrees north. When we talk about the length, we mean the total distance around this small circle, which is the parallel of latitude for 6 degrees north. That will give us 2 pi r as the circumference of the small circle, but r, which is the radius of the small circle, r, but r is equal to r cos alpha. So our equation becomes 2 pi r cos alpha. So let's put in 2 pi is 3.142 times 6,400 times cos 46 degrees. 2 times 3.142 times 6,400 times cos 46 to 27,907.49 kilometers. So the question says our answer should be correct. So the A part says the answer should be correct to the nearest 100 kilometers. So these are our units. This is a tenth. This is 100. The answer will be 27,900 kilometers to the nearest 100 kilometers. So that's A. B, the shorter distance between K and Q corrects to the nearest 100 kilometers. The shorter distance between K and Q measured along the parallel of latitude. So the distance between K and Q, the shorter distance between K and Q and the parallel of latitude. This is degrees north is equal to theta naturally 60 degrees times 2 pi r cos alpha. So angular difference in longitude, that is theta is equal to longitude 130 degrees minus 102 degrees. 27 degrees. So distance KQ, distance KQ is equal to theta 27 degrees over 360 degrees times 2 times 3.142 times 6,400 times cos 46 degrees. So 27 times 2 times 3.142 times 6,400 times cos 46 77543 12.297 divided by 3, 60 degrees. Divided by 3, 60, 2095.31 kilometers. Approximately to the nearest 100 kilometers. So unit times 100, so 2100 kilometers. So the nearest 100 kilometers. Okay, that's the answer. C. C says the shorter distance between Q and P measured along the parallel of latitude to the nearest 10 kilometers. So the shorter distance between Q and P measured along the parallel of latitude 6 degrees north for the theta actually 60 degrees times 2 pi r cos alpha. Before we proceed, let's get our angular difference in longitude. Angular difference in longitude is theta is equal to, now Q and P are on different sides of the globe. Q is on the west, P is on the east. So that means we're going to add the longitudes together. So longitude Q is 103 degrees, 103 degrees plus longitude P is 23 degrees east, 23 degrees. So 103 plus 23, 126 degrees. If a distance and P distance QP or PQ, distance PQ is equal to theta 126 degrees over 360 degrees times 2 times 3.142 times 6,400. Okay. That's equal to 126 degrees over 360 degrees times 2, 3.142 times 6,400 times cos 46 degrees. Distance PQ is equal to distance PQ is equal to, right to side, go to there, 126 degrees over 360 degrees times 2 times 3.142 times 6,400 times cos 46 degrees. So 126 times 2 times 3.142 times 6,400 times cos 46 3520 124.052 over 360 degrees divided by 360, 9778.12 kilometers. The question says our answer should be correct to the nearest 10 kilometers. Approximately unit tens. So our answer will be 9780 kilometers to the nearest 10 kilometers. Point A is 50 degrees south, 20 degrees east. and point B is 50 degrees south, 160 degrees west. At 2 points on the Earth's surface, calculate A, the speed of A due to the rotation of the Earth. B, the distance between A and B along the parallel of latitude. C, the distance between A and B along a great circle. So point A, 50 degrees south. Right. Okay. 50 degrees south. So this is latitude 50 degrees south. And then to point A, 20 degrees east. Longitude 20 degrees east. So this point A. Then point B, 50 degrees south, 160 degrees west. 160 degrees west. Longitude 160 degrees west. Point B. A and B are on the same line of latitude. So, okay, I can complete it. So this and the radius of this small circle. So this is the radius of this small circle. Okay, so A says the speed of A due to the rotation of the Earth. The point A travels. The point A travels through 2 pi r in 24 hours. The 2 pi r is the circumference of the small circle. So point A will travel through 2 pi r, will make a complete revolution in 24 hours. So speed is equal to 2 pi r over 24, but r is equal to r cos alpha. So speed of point A is equal to 2 pi r cos alpha over 24. This is equal to 2. Now, whenever the value of pi is not given from the question, you can use the usual value for it, which is 22 over 7 times 6,400. Same thing with the radius of the Earth times cos 50 degrees, because point A is lying on latitude 50 degrees south, cos 50 degrees divided by, so everything here will be over 7 times 24. And so let me come over here. Equal to 2 times 22 times 6,400 times cos 50 181,008.99 divided by 7 times 24, 168. So that will be equal to 181,008.99 divided by 168. 1077.43 kilometers. The question says the answer should be correct. So, okay, but no values in, so I'm going to correct mine to raise significant figures. So 1, 2, 3, and I'm giving 1080 kilometers to to two significant figures. So that's the distance, sorry, that's the speed of point A due to the rotation of the Earth. This is the distance between A and B along the parallel of latitude. So distance AB along the parallel of latitude is equal to theta, let's rate 60 degrees times 2 pi r cos alpha, angular difference in longitude, that's theta is equal to 160 degrees west plus 20 degrees east, that is equal to 180 degrees. So distance, so AB, arc AB is the distance between A and B, which is this line. Arc AB or minor arc AB is equal to, the theta is 180 degrees, divided by 360 degrees times 2, 22 over 7, and 6,400 times cos 50 degrees. So 180 here 1, 2 here is 2, 2 here 1, 2 here 1. So 22 times 6,400 times cos 50 is 90504.495 divided by 7. That will be equal to 12929.21 kilometers. So approximately, to three significant figures were given: 12900 kilometers to three significant figures. So C says the distance between A and B along a great circle. So along a great circle means we start a measurement measured along the equator. When you can be measured. So this will give us a great circle from equator. So along a small circle or the parallel of latitude, that means it's measured along the parallel of latitude. But for along a great circle means either it's measured from the equator or it's measured on all the 2 points lie on the same longitude. So let's look at our angular difference here would be, now take note, when we did angular difference here, difference in longitude was 180 degrees. So this tells us that since the longitudes of A and B differ by more than 80 degrees, it implies that A and B lie on the same meridian. This is what we're going to have. This meridian, and then we have here point B, then point E. So the angle here is 50 degrees. The angle here is 50 degrees. Now, how we arrived at this is from, since both A and B are on parallel of latitude 50 degrees south, so the angle inclined here is 50 degrees, and that, so by alternate angle, here's 50 degrees. Same here, 50 degrees. By alternate angle, here's 50 degrees. Or we could say that this part, this shape, Okay. So let's say AOB. So A angle OB is equal to 180 degrees minus 50 degrees minus 50 degrees. Y sum of angles on a line. So this angle here would be 180 degrees minus 100 degrees, which is equal to 80 degrees. So E is 80 degrees. So that will be our angular difference. So therefore theta, so distance AB along great circle is equal to 80 degrees over 360 degrees times 2 times 22 over 7 times 6,400. Two 5 2 8 0 0 0 divided by 2 5 2 5 2 0. 8929.68 kilometers. The three significant figures, the answer is 8940 kilometers to three significant figures. An aeroplane leaves a point P 21 degrees north, 32 degrees east, and flies due south at 850 kilometers per hour. Find its position Q after 4 hours. Assume that the Earth is a sphere of radius 6,400 kilometers. So number 4. North, south, west, east. So P is 21 degrees north. Latitude 21 degrees north, 32 degrees east. Longitude 32 degrees east. And flies due south. So this is P. And so that's P point P. And flies due south. So due south at 850 kilometers per hour. Find this position Q. So I'm going to look for position Q as the latitude of Q. Assume that the Earth is a sphere of radius. That's point Q. Now, and flies due south at 850 kilometers per hour. Find its position Q after 4 hours. Both points are on the same line of longitude, so that indicates a great circle. The distance between P and Q is on a great circle. Since both points lie on the same longitude, so let's go. Okay, and distance PQ, and extra information is given to us here. So we're given time, 4 hours, and speed. So which means we can get the distance from the time, and so speed is equal to distance over time. So distance is equal to speed times time, and the speed is 850 times 4. 850 times 4. 3,400 kilometers. So 3,400 kilometers is the distance. The distance from P to Q. So distance PQ is equal to theta. Theta is the angular difference over 3. Since both points lie on the same longitude, theta is the angular difference in latitudes. So we need the latitude of P, and we are going to look for the latitude of Q. So theta is over 360 degrees times 2 pi r, a Greek circle. Distance PQ is 3,400 kilometers. So 3,400 theta over 360 degrees times 2. We're not given the value for pi, so we use the usual value, which is 22 over 7. And r is 6,400 kilometers. 6,400. So 3,400 is equal to 2 times 22 times 2816. 281600 theta. 360 degrees times 7 is 2520. So cross multiplying. Cross multiplying. So 281600 theta for 3,400 times 2520. 856 856 theta is equal to 856 800 divided by 281600. Theta is equal to divided by 281600. 30.43 degrees. So theta is approximately 30 degrees to the nearest degree. But you know that theta is the angular difference, and then since it's an angular difference, for us to know the latitude of Q, the angular difference, this is theta, is the value of theta, and theta is the angular difference, but theta is equal to angular difference in latitude, angular difference in latitudes in this case. So theta is equal to, so angular difference in latitude will be the difference between the latitude of P and the latitude of Q. And P is in the north, Q is in the south, so which means we're going to add both latitudes together. So that will give us the latitude of P 21 degrees plus the latitude of Q, which in this case we are going to use y to represent it. So y is equal to 21 degrees minus theta. So y is equal to 21 degrees minus 30 degrees. Now you wonder that why are we going to get a negative value? We're going to have a negative value, but we're not going to write the negative value. 21 minus 30 degrees will give us minus 9, but y is 9 degrees rather. But mathematically 21 minus 30 is minus 9. The negative value is there because it shows that Q is opposite to P. In other words, Q is in the south while P is in the north. That's why in this working is 21 minus 30 degrees, but we're not going to write the negative sign here. The minus sign only tells us that Q is opposite P, or opposite to the latitude of Q is opposite to the latitude of P. That's what it means. So y is equal to 9 degrees. So I'm going to say, therefore, the latitude of Q is 9 degrees south. Hence, the position of Q is 9 degrees south. Since Q is on the same line of longitude as P, 9 degrees south, 23 degrees east, 32 degrees, 32 degrees east. So this is the position of Q. Number 5, find the parallel of latitude in the northern hemisphere along which a journey of 640 kilometers makes a change of 8 degrees in longitude. Number 5. North, south, west, east. So, latitude. Okay. In the northern hemisphere along which find the parallel of latitude in the northern hemisphere along which a journey of 640 kilometers makes a change of 8 degrees in longitude. So there was a change in longitude, a slight change. So these are the 2 points. So let's call the first point E, next point B. So it's on this is the radius. Okay, and let's call it the center of the small circle C, and let's also bring it closer to this point. So point C, so the equator will give us theta, and then by alternate angles will give us theta. So this is R. So we are going to look for the value of theta, which is the find the parallel of latitude. That's what this part of the question means. The value of theta is related to this angle theta on the equator. And now we're told that the 2 points A and B, the distance between them is 640 kilometers. So let's show it this way. So the center of this small circle is C. This point. A little change. Difference in longitude is 8 degrees. That is the angular difference. And arc AB, which are the 2 points, is 640 kilometers. That's the implication. So what we need to look for here is the parallel of latitude, the angle, which is theta here. So I'm going to say distance AB is equal to theta over 2 is 60 degrees times 2 pi r. 2 pi r cos alpha. So here's the radius. So yeah, 2 pi r, and r here is the radius of the small circle, and the radius of the small circle is related to the radius of the big circle by, but r is equal to r cos alpha. So the formula is equal to theta over 2 is 60 degrees times 2 pi r cos alpha. And distance AB is equal to 640, and then the angular theta, which is the angular difference in longitude, is 8 degrees. 8 over 2 is 60 degrees times 2. Pi is 22 over 7 times 6,400 times cos alpha. That's what you're looking for. So 640 is equal to 8 times 2 times 22 times 6,400, 225, 2800 cos alpha. Divided by 260 degrees times 7 is 2520. So cross multiplying, we're going to have 2800 cos alpha is equal to 640 times 2520, 161 1612800. So cos alpha is equal to 1612800 over 2252800. So alpha cos alpha is equal to divided by 2252800, 0.71 0.7159. So alpha is equal to arc cos 0.7159, and alpha is equal to shift cos 0.7159, 44.28 degrees. So alpha is approximately 44 degrees to the nearest degree. So therefore, the parallel of latitude is 44 degrees north. Number 6. Sidi Barani, Egypt, and Gaborone, Botswana, both lie on longitude 25.9 degrees east. Their latitudes are 31.6 degrees north and 24.8 degrees south, respectively. Calculate the shortest distance between the towns. So let's get Sidi Barani. Both lie on longitude 25.9 degrees east. So, longitude 25.9 degrees east, and then 25.9, latitudes are 31.6 degrees north. So this is latitude. Okay, latitude 31.6 degrees. This is Sidi Barani, Egypt. Let me use letter E to represent it. Egypt. And Botswana, 24.8 degrees south. 24. So latitude 24.8 degrees south. This is where Botswana, Sidi Gaborone is. So the question now says, respectively, calculate the shortest distance between the towns. The shortest distance between the towns is the arc, or minor arc is the minor arc DE, which is a great circle, route. So since both of them are lying on the same line of longitude, they can be measured from the equator. So the angular difference between them, theta. So we have this, and this is the radius of the great circle. So E25, the latitude of E is 31.6 degrees, and the latitude of B is 24.8 degrees. Therefore, the angular difference in latitude, which is theta, is equal to 31.6 degrees plus 24.8 degrees. 31.6 plus 24.8, 56.4 degrees. 56.4 degrees. So distance BE, distance BE along the line of longitude, along the line of longitude, 25.9 degrees east equal to theta over 60 degrees times 2 pi r. So the theta is 56.4 degrees over 360 degrees times 2 times 22 over 7 times 6,400. 56.4 times 2 times 22 times 6,400, 882240 divided by 2520. 6302.48 kilometers. So I'm going to correct the answer to the nearest three significant figures. 1, 2, or to the nearest two significant figures. 6300 kilometers to two significant figures. So P is on, let's get the equator first. As the equator. So point P is longitude 173 degrees east. Longitude 173 degrees east. And then point Q is on 75 degrees west. 75 point Q, 75 degrees west. This will be us. -5 degrees west. Okay, so the question is, what is the shortest distance between them along the equator? So the shortest distance between them is the minor arc. It's a minor arc. So let's do it here. Okay, so we have here. So this is central, this is the equator. So there's a P is here. So this is P, minor arc. So let's say this Q. So point P, point Q. So all the way down to this point is longitude 172 degrees east, and from here to Q is 75 degrees west. So if you add both of them together, the angular difference would be, so it's a minor arc. So this PQ, this part here is a minor arc. Right from here to PQ is a major arc. We're going to use the minor arc instead. It's the minor arc PO, P angle OQ, and that's equal to POQ. So P angle OQ is equal to 180 degrees. It's equal to 360 degrees. That is angle at a point. 360 degrees minus 75 degrees, 75 degrees plus 1, 173 degrees, 360 degrees minus the reason here, angles at 8 points. 75 plus 1, 7, 248 degrees. So 360, 112, 112 degrees. So that's our angular difference, and also that's what we are going to use in our calculation. So the shortest distance between them is the minor arc POQ, and also the shortest distance between them, since from the equator, that's a great circle. So distance PQ is equal to theta, equal to theta over 360 degrees times 2 pi r is equals to 112 degrees or 360 degrees. Times 2 times 22 over 7 and 6 6,400. So 2 times 31 529 529 2 0 divided by 3. This degrees times 7 is 2520. This gives us 125.56 kilometers approximately. So three significant figures: 12,500 kilometers to two significant figures. So that's the final answer for part A. Now this is how far is Q from the South Pole. So Q to the South Pole is north, south, west, east. So the distance between Q and S from the South Pole is arc QS. So the distance of Q from the South Pole is arc QS, and that is a great circle. That is a great circle. So arc QS is equal to theta degrees. So from Q to S, measure from equator, so that will give us 90 degrees. 90 degrees over 360 degrees times 2 times 22 over 7 times 6,400. That is 90 here 1, 90 here 4, 2 here 1, 2 here 2. So 22 times 6,400. 1,40800. 2 times 7 will give us 14. 1,40800 divided by 14. 10057.14 kilometers approximately. So three significant figures: 10100 kilometers. Three significant figures. And let me just state that the reason why the angular difference is 90 degrees is because Q is on the equator, and you know from the equator is 0 degrees. The equator is a line of latitude that's equivalent to 0 degrees. while the South Pole is 90 degrees. So from the equator down to the South Pole is 90 degrees. From the equator up to the North Pole is also 90 degrees. So if you take your angular difference, theta, you're going to have 90 degrees minus 0 degrees, which is difference in latitude. So that will give us theta is equal to 90 degrees. Find the distance measured along the parallel of latitude between 2 points whose latitudes are both 56 degrees north, whose longitudes are respectively 23 degrees east and 17 degrees west. The latitude is 56 degrees north. The latitude is 56 degrees north. And the longitudes are 23 degrees east. Longitude 23 degrees east and 17 degrees west. Longitude 17 degrees west. Let's call it point P, point Q. Both P and Q are lying on the same line of latitude. So this is the center of the latitude. And these are two connecting points. So the question says we should find the distance between P and Q. So angular difference in longitude that is theta as will give us 23 degrees plus 17 degrees, since both of them are on different parts of the globe. 23 plus 17 will give us 40. 23 plus 17 degrees. Sorry, 23 plus 17, 40 degrees. 40 degrees. The distance PQ along the parallel of latitude. When the parallel of latitude 56 degrees north is equal to theta over 60 degrees times 2 pi r cos alpha. So theta is 40 degrees over 60 degrees times 2 times 22 over 7 times 6,400 times cos. This is 6 degrees. So 40 here, 1, 40 here, 9. So 2 times 22 times 6,400 times cos 56. 1, 5, 1, 5, 7, 4, 6, 8, 1, 5, 7, 4, 6, 8, 1, 7, 2, 1, 6, divided by 9 times 7, 62. That's so this is equal to 157468.7216 divided by 63. 2499 2499 2499.50 kilometers, approximately 22500 kilometers. two significant figures.